Last lesson we looked at the causes of flooding, and now we're going to look at how we can stop the detrimental effects of flooding through flood management. So the definition of flood management is those strategies and methods that are used to reduce or prevent the detrimental, and when I mean detrimental, I mean negative effects of flooding. So the first thing to consider in flood management is prediction. We need to know when floods are going to happen, and we can do that best by looking at rainfall data, which would normally come from somewhere like the Met Office. They would be able to tell us the times of year when we have more rainfall and therefore more likely to flood, but also you can get such updated live data that we might be able to tell if there was going to be an extreme event. We'd also need to know where the areas were most at risk. So you might have areas that are incredibly low lying, which would be more at risk, or places that don't have natural barriers. But these would be areas we need to focus on because they are more likely to flood. We'd also need to be monitoring rivers which had flooded in the past and therefore were likely to flood, as this would give us a better indication of if they would flood again. Once you have this information, you can then convert it into a flood risk map, like I have for this one of the Radley area, which shows you the extent that they would predict the flooding would occur, and therefore you can make strategies, whether hard engineering or soft engineering, that would be able to deal with the extent of the flooding. So there are different ways in which you can control flood water. One of the main branches is something called hard engineering. This is where we use construction. This is where we build up structures, and we do this so we can either hold back or we can safely remove any of the flood water that has been created. In terms of holding back the water, we have examples of hard engineering which would include dams and levees. So levees is where you build these artificial banks. Dams, obviously the water would be kept behind the dam and then slowly released to stop kind of flood water spreading out naturally. And in terms of safely removing, we have flood relief channels. These are channels that are normally made out of concrete, and they would divert flood water away from the main river. But you also get channelization, or the straightening of a channel, which I'll just highlight here. This is where we are making sure that the river goes in a straight line. We're making an artificial straight line in the river, so removing that meander loop, and therefore that means that the water can go very quickly through the area it needs to, rather than around that kind of meander band there. Here we have the Mississippi River, and we can see an example of hard engineering here. We have a levee embankment. This is this raised mound of earth that is right next to the river, and this goes all the way along this side. It's called the Algiers levee, and as you can see, it's raised, and that means the capacity of the Mississippi is increased because it can fill up to a higher level because it's got this raised bank. And as you can see behind, there's been lots of development behind it. All of this whole community is protected by that levee. Here's another example of a hard engineering technique. This is the River Lee, but they've actually got just here, this is what we call a flood relief channel. So if the water does get too high, then the water can be released down this channel, which takes the water away from the main river and stops it flooding, and this can be stored somewhere else until the flood has passed. So that is a flood relief channel. It's another example of hard engineering and safely disposing of floodwater so you don't get flooding in the main river, which is just over here. So hard engineering does have benefits. It can make the river hold more water, and when we have flood conditions, it can also make sure that water is redistributed somewhere else so that we don't actually get flooding in key areas. However, hard engineering also has negatives. Because we're having to make these giant structures largely out of concrete and metal, it will cost a lot of money to do that, and that means that certain areas or certain countries might not actually be able to afford them. With all this use of concrete and metal, putting it into a natural environment, we will obviously see damage to ecosystems, and we saw that when we talked about the Three Gorges Dam, how when we built a huge dam in that area, that it actually affected the aquatic life, when you had silt that would naturally go down the river being trapped behind the dam, which would eventually have to be removed. Even once these structures are built, they need to be maintained. They can't just look after themselves. And we've had examples where flood defences haven't been maintained. A good example was in New Orleans, on the Mississippi, where the levees weren't maintained, and when Hurricane Katrina came, that brought flood-like conditions, and that means they were breached because they weren't able to hold the amount of water they should have, and unfortunately it meant a large number of the people of New Orleans, mainly the black community, suffered some very severe flooding and consequences because of that. When we also build certain hard engineering structures, it gives us a false sense of security. So if we build levees or embankments, it encourages us maybe to do behaviour that we wouldn't normally do if we didn't have them. So it could mean that we build on floodplains and build in high-risk areas. And this is particularly dangerous because you can sometimes have flood events that happen once every 100 years. And if that does happen, it can overtop those hard engineering defences, which means the people that previously thought that they were protected actually suffer flooding despite having these defences put in the first place. So the opposite of hard engineering is soft engineering, and we can see that in this picture here, where the river has been freely allowed to flood across the land surrounding it. So soft engineering is where we do that. We try to work with the natural conditions of the river, so we don't try to hold it back or control it. This can be done sometimes where there has been hard engineering. We actually remove them, so we restore the river back to its natural state. And we also might try and preserve some of the natural barriers that actually can hold back floodwater. So we preserve floodplains, and we also look after things like wetlands. And these act as natural sponges. So when it does flood, they kind of absorb the water temporarily, which means that kind of human settlements aren't sacrificed or inundated. Other techniques could involve afforestation, which means that we have lots of trees being planted, and obviously they intercept rainfall, and that means that there's not so much surface runoff, and therefore we're less likely to get flooding conditions. Here's an example of restoring a river back to its natural conditions. So this is the River Skern in Darlington, and what they did is they straightened the river to make sure that the water could go through the town very quickly. Unfortunately, that meant that it sped up and it led to more flooding downstream. So what they did here is they restored the natural meanders in the river. So now it's back to its natural path, and this has actually helped reduce the flooding downstream. An example of soft engineering that is happening right on our doorstep just up in Oxford, I've circled two areas, and we've got here a meadow next to the River Thames, and we've also got some sports pitches. And the reason that they've been put there is something called flood plain zoning. That means essentially there are restrictions put on what you can actually build on certain bits of the floodplain, and they leave these areas because they're relatively low cost in terms of if they flood, it doesn't matter. Their value is not that high, and so they act as natural barriers. This is soft engineering because we're not trying to hold the river back, but we're saying if these areas flood, it's not a significant loss, but if we had put housing in this area and they did flood, that would cause significant economic damage. So that is about making restrictions, and people like the council saying you can't build on this area, but we can leave these areas to be flooded if a flood does occur. So as with hard engineering, soft engineering does have both pros and cons. It's often cheaper because you're not having to build these huge concrete structures, and it doesn't take a lot of money to maintain. Once it's been made, it is there, and that makes it very sustainable, especially because you're not having to do so much to the actual physical environment. So it's sustainable in terms of maintenance, but also in terms of the environment. It's a long-term solution. And it can also have benefits. It can create habitats. So the wetlands that are created can often be habitats for birds. However, it just isn't as effective as hard engineering. These areas still flood. That means people are still at risk. Possessions are still at risk. And also, it can't be used everywhere. So if there's an area, a city in which the floodplain has already been built on, you can't just let that area flood because that would cause significant damage. So there are both pros and limitations to soft engineering. Another way that we can mitigate against the issues of flooding is through an early warning system. Here's a basic example of one. We can see here in the left-hand corner that as the water has risen, that is triggered a sensor that is in the water, and what this does is this transmits a message to local receiving stations, and eventually that gets analysed and interpreted, and they check if there's a flood, and then that will, if there is flood conditions, be sent to local people. Here is an example where it's been sent by text message, but it could be on local news. That is a way for people to make adjustments so they can maybe leave an area if they have to, and to stop the consequences of flooding from being so disastrous. The last thing to consider when thinking about flood control is at what level should a local council or government protect a river. So if I look at this graph, I can see that most of the flood events that happen on this river, they happen below this 1.5 metre level. So if I protected that level, I would protect most of the area from flood events. However, I've got these anomalies above it. What do I do about these events? If I wanted to protect against these, it would be lots more money and investment and construction. It would be more expensive to protect. And the question I have to ask, is it worth it? So would I, for these what we would call 1 in 50 year or 1 in 100 year events, is it worth investing all that money to do it when I can protect these 5 and 10 year events much more easily? That is the kind of constant battle that river managers and local councils and governments are having to have when managing rivers.